So 7-2, just remember it's on the backside of 7-1's practice, so grab that. And last time we did binomial times binomial. Today is just polynomials times polynomials. Like, can you see on number 1, this is a binomial, and we are going to take it times a what's not a binomial when it's got 3 terms. It's called a trinomial. Simple process, man. Like, it's still the distributive property. Here's what I want to get through your head today: how to keep yourself organized when you start multiplying all this stuff out. It's not about how to do it. It's like how to not get lost doing it. Does that kind of make sense? So, hey, real quick, last time I was always talking about 2 dudes times 2 dudes should give you 4 dudes back. Check it out. What do we do now? 2 dudes times how many dudes? 3 dudes. Shouldn't we get 6 dudes back? Would you believe 2 dudes times 3 dudes should be 6 dudes? So we shall do the same strategy. We will distribute. Let's take this n and distribute it to all 3 of those guys. So n times n squared, wouldn't that be n cubed? Are we okay with that? And then n times a positive 5n would be plus 5n squared. And then finally, n times 9 is a positive 9n. And here's what I'd like to show you. This is a strategy that I learned from a student. I was watching them do homework probably about 10 years ago, and I was like, dude, that's cool. I have never seen someone keep themselves organized like that. It's like, I'm going to steal that and teach that to the kids, right? So are we cool with taking like the n times everybody, right? So now strike him out, and here's what I call the technique that I learned from that student. Call it stacking, right? We're going to start stacking these guys. So can we take 3 times each one of these guys also? But instead of continuing on in this fashion, right, I'm going to stack them on top of each other. So what's 3 times n squared? 3n squared, so it's a positive 3n squared. And then 3 times 5n is 15n, and 3 times 9 is 27. And why I like this stacking procedure is I can easily tell that I got my 6 dudes back, right? So 2 dudes times 3 dudes is 6 dudes. It's like, okay, I got a level of 3, then I got another level of 3. It's like I didn't miss anybody, right? It's going to get messier and messier and messier. If you look down the sheet, don't we have 3 dudes times 3 dudes? That's going to give us 9 dudes back. It's just like it starts getting messy. Do you have them? Now, let's combine any like terms. N cubes is who we'll start with. There is only the one of them, right? So are we cool that we have n cubed? Some students like to strike that out to realize they've dealt with it also. That's up to you. Then n squareds. Here's a strategy that I kind of noticed. Like a lot of times they line up diagonally. Do you kind of see like the like terms are lining up diagonally? Some people like to even just line them up directly on top of each other. They're like, hey man, if we're going to start stacking these, why don't I just put like all my n squareds on top of each other, put all my n's? And that's up to you. I think that gets messier personally than you think it's going to be, when you try to start doing that. So I just stack them like this. So I have a total of 8n squareds. Are you with me on that? And then when it comes to plain Jane n's, that is 15 plus 9 is 24 of them, and then 27. So what a mess, right? 2 dudes times 3 dudes gave me 6 dudes back in that case. Like I said, don't work ahead of me because I'm changing a bunch of these questions to make it match more like homework. But did you feel okay with that? Just the distributive property, and we'll stack. So let's do that one more time. Let's take this y times each one of these guys, and then check it with mine. I also make mistakes, so make sure I did not make a mistake. So 5y cubed plus y squared minus 4y. Cross him out. And then, of course, the big error that we make is like sometimes sign errors. We're not going to distribute a 2 through. What number is it really? It's not a 2. It's a negative 2. Right? So minus 10y squared minus 2y plus 8. There's my 2 dudes times 3 dudes giving me 6 dudes back. Right? Got my 6 dudes, then looking for like terms. Most of the time, not all the time, most of the time, they'll line up diagonally in that case. So 5y cubed minus 9y squared minus 6y's and then plus 8. One weird thing that I do see happen is sometimes I almost did it myself. You see these guys right here? Like when I was combining like terms, I almost wrote 8y squared. Like I almost multiplied them together instead of adding them together. So just kind of watch yourself. We know what we're doing, but sometimes when we don't concentrate too hard, it's like, oops, my bad. You feel all right with this? It's just the distributive property. So let's roll it again. Check it out. Here it is. Trinomial times trinomial, a.k.a. 3 dudes times 3 dudes. How many dudes should you get back? 9 dudes. This is where the stacking really makes a difference, in my opinion. Like if you start stacking them, you really, really do well with it. So let's take this x squared and distribute. What's 4? Well, obviously I'll get the 4, but what's x squared times x squared? X to the 4th, right? Remember we add the exponents there. And then minus 8x cubed, right? And then plus 1x squared, where I'm not going to actually write the 1. Then I'm going to lightly strike that guy out, realize I am done with him. And now we just move to the next brother, which is this 2x, and we distribute him. And if we stack them, we'll be in nice, neat organization. So 2x times 4x squared is 8x cubed minus 16x squared, and then plus 2x. I could care less if you draw those arrows that you're distributing with. That's up to you. You know, like some people like them, some people, they just start getting messy. It will start getting messy. You'll have like 9 arrows up there, and it's just like, holy cow. So it's up to you if you need those or not. And then the third level, I'm going to take this 3 and distribute him through. So that would give me 12x squared minus 24x's plus 3. And man, long time ago, I just like would have that all written out as one long line, and there's 9 terms in there. You get lost. It's hard to find like your like terms also, but with this stacking, it's just straight butter, baby. You know, it's like looking diagonally, you get all your like terms. Most of the time, your like terms are diagonal from each other. So sometimes it doesn't happen, but in this case it does. So let's start with the highest degree, 4x to the 4th. Got him. Ooh. What happens with these x cubes? Here's a minus x cubed, 8x cubed, and a plus 8x cubed. What happens with those? They're gone, right? So we won't write them down, right? There's 0 of them. And then nice to grab a calculator and kind of get all those x squareds. So if we add all those up, negative 12 minus 16 is negative 4 plus 1 more. Is that minus 3x squared? Did I do that correctly? There's 1x squared. Take away 16x squared plus 12 more x squared. Isn't that minus 3x squared? Are you with me on that? So, and then how many x's? A 2x and a negative 24x is how many x's? Negative 22x. And then plus 3. These are just called polynomials when they have like more than 3 terms. 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. After that, it's polynomials. Poly means many. Cool? All right, I will let you and a neighbor try number 4, man. Let's try to keep the letters in alphabetical order. Do you see how they're using M's and X's, right? You know, so let's call them MX's. Does that sound okay? You know, it's not wrong to call them XMs, but I like to do them in alphabetical order. So 3 dudes times 3 dudes should be 9 dudes. Boom. And then trying to call them MX's is what I said I'd like to do. It's not wrong to call them XMs, but if you're going to call them MX's one time, you might as well call them MX's every time. Much messier. Much messier, this one. Sometimes the arrows help. Much messier. this got messier because it had different letters with it. It had some X's and it had some M's, right? And before I go through any combining of like terms, I always look to see if I got my 9 dudes back. Like 3 dudes times 3 dudes is 9 dudes. Did I do it right? Double check with mine, you know. Are we okay? And we'll combine like terms together. Like we still might have some like terms. Yes? All good? Cool. How do I do like terms? I just start up here. These are m squareds, right? I'm going to go looking through the rest of this. Do I have any other m squareds? I don't think so. So 5m squareds. Cross them out. Next thing I see is some mx's. You can tell the diagonal trick doesn't work this time, right? You know, just looking diagonally, it's like, hey, what just happened? It's because of the different letters, right? You know, so you got to go searching. So here's some mx's. Oh, there's some mx's, right? You know, any other mx's anywhere around? So we'll add those up. Negative 29 mx's. And I like to strike them out, because that way I don't have to look at them when I'm looking for other stuff, right? Keep going. See if you can find any other like terms. Order is not important of how to put them in when it's all wild and wacky like this, so it's just whatever. So here's some m's. Here's some m's. Minus 41 m's. Then some x squareds. And some x's, and then some constants. You can have those in a different order. I couldn't even personally fit all 6 of them in a row, at least on my screen. You probably won't be able to do that on the test, like in the little answer blank, you know. So I like to see how I kind of stacked them there also. It's all good, right? Having them in a different order is okay when they use different letters. Like if they were all m's, like over here, they're all x's. Do you see how I went like from the exponents from biggest to smallest all the way down the row? But when you got all the mixes and matches, nothing crazy. Sound okay? Cool. Let's mix it up. How is number 5 different than the first 4 that we have done? What's different about number 5? 3 things times each other, right? 3 things times each other. So it is impossible, dear friends, to take 3 things times each other in one move. Let's make it simple. 5 times 2 times 7. You cannot do that in one move. You have to just do 2 at a time. Don't you need to take 5 times 2 first? What's 5 times 2? 10. And then you take that result times 7, and you get 70. Right? You see, it is impossible to multiply 3 things together at once. Right? You just got to do 2 of them. So how about orange guy times pink guy? Can we take orange guy times pink guy? Right? Let's do that. We're just going to pick on 2 of them. Right? So we'll do the distributive property. X times x, x squared. Keep going. Plus 3x, plus 8x, and then plus 24. I took 2 dudes times 2 dudes, and I got 4 dudes back, right? Would you also believe we have not dealt with that green guy up there yet either, right? He has to be brought down and multiplied. Here's my question. Would you rather do it the hard way or the fast way? Do you want to take 4 dudes times 2 dudes, or could you combine some like terms before you get started and only take 3 dudes times 2 dudes? Like, are there any like terms in this guy right here? So we'll bring him down. X squared plus 11x plus 24. Please, 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 we got to put that in parentheses, and then we'll take him times that green dude. So do you see the green guy has to come down and join the party? And now, this is interesting. We have the guy that's got more dudes on the left compared to the dudes on the right. So our stacking gets a little different, but still, when you take 3 dudes times 2 dudes, how many dudes should you get back? 6 dudes, right? So the stacking just gets weird because we'll do x squared times x. That would be x cubed. And then x squared times a negative 2 is a negative 2x squared. And if you're like, you know what, I don't necessarily need to stack, fine. You don't have to stack. You have to get the right answer is all I care about. But some people still like to stack. So if I go 11x times x, that would be 11x squared. And I just started a new line. And then 11x times negative 2 is negative 22x. And then to stack it one more time, I would ask you so nicely, when you do 3 dudes times 3 dudes, to like stack, you know, like please, that makes it easier for me to grade what you did, you know. But here, if you really wanted to write all 6 of these dudes out in one line, it's not like it's wrong. It's just like, I think the stacking is nicer, especially because you can see your like terms. The like terms still line up nice and diagonal in that case, right? So, all right. So x cubed plus 9x squared plus 2x minus 48. If we would change number 6 to be, like, just cross that guy out, and let's write these 3 parentheses down, and then I'll give you some advice. So first parenthesis is x plus 1. Second parenthesis is y plus 3. And the third parenthesis is z minus 2. 2 bits of advice. Advice number 1 is the letter z in this problem. We're going to cross it because z minus 2 looks really weird when you don't have a cross in your z, right? Don't get lost. 2 z's looks like 22's, all that stuff. Here's what we were working on last time. Up to this point, have we had like terms? Yes or no? Have we had like terms to combine? What letter is it? My bad. What letter is in the green group right here? X. Are there any X's in other groups? Nope. This has Y's. Any other Y's in the group? Nope. Z's. Any other Z's in the group? Nope. We will not get like terms once we multiply this all out, right? So it is 3 things times each other, though. So let's start by taking the green guy times the red guy, right? Let's do that. Green guy times the red guy. Go for it. So xy plus 3x plus y plus 3. 2 dudes times 2 dudes. I got 4 dudes back, and none of them are like terms. Would you be cool with that? None of them are like terms. Throw parentheses around the whole group, and then let's take it times the purple dude. Time out. Let's realize why the parentheses matter. What if you didn't have parentheses? Let me get an eraser and make it small. What if you didn't have parentheses and you just put a multiply sign right here? What does it look like you are taking times those parentheses? Just the 3. The only thing that's being multiplied by the parentheses now is the 3. Like, there is nothing that's making you take this y times the parentheses, this x times the parentheses, or this xy, unless you put it in parentheses. Cool? So let's do it. 4 dudes times 2 dudes. How many dudes should you get back? 8 dudes. Multiplier out, please. So xyz minus 2xy. Done with it. Then I'm going to do like a modified stack. You're welcome to stack all 8 of them on top of each other in 2's, but I'm going to do 4 at a time. 3x times z is 3xz. 3x minus times a negative 2 is a negative 6x. Cross him out. Then I'm going to stack down below that. Y times z is yz, and y times negative 2 is negative 2y. And one more, 3 times z is 3z minus 6. And the beauty of having a little bit of weird polynomial knowledge before you do all that is I don't even need to go hunting for like terms. I knew before I started I will not get like terms back. That's also why I didn't stack these, is because I was going to know I was like just going to put this in the answer. So it's like, why have an answer that's like 2 by 4 when I could go 4 by 2? All I care about is you get all 8 of those guys there properly, though. That's really the important part. Pretty exciting, eh? Nice. Let's try this one. How many things multiplied together? How many sets of parentheses multiplied together is a better way to write that. How many sets of parentheses? Just 2, right? So we don't have to like bring a guy down or anything like that. So let's do it. Hey, before we do it, will there be like terms? Does the first group, it has y's with it, right? Does the second group also have y's with it? That's what matters, is group to group, right? You know, do they have the same letters? So let's multiply. Go for it, and then check it with mine. So 2y times everybody will be 2y to the 4th minus 2y cubed plus 4y squared. Peace out. 3y times everybody would be 3y cubed minus 3y squared plus 6y. Peace out. And then 4 times everybody, 4y squared minus 4y plus 8. And then we combine all the like terms. 2y to the 4th, gone. And then those plus y cubed, gone. 4y squared, 8y squared, 5y squared, and then 2y plus 8. You can do the last one as well. That's why I also ask you to lightly strike things out, because if you do have the wrong answer, I got to go back up through all of this stuff and see if we made any sign errors or things like that. And if you black it all out, I can't see what you did, right? So you can lightly strike things out, but you can see even by me circling that weird thing, I made a mess. You're welcome to highlight those things also, you know, like how I was highlighting things diagonally. Like, you can color it up all you want, just as long as I can read underneath there what you wrote, you know. But pretty fun one here. P's, Q's, and R's. And then some P's minus Q's and minus R's. See what happens with all this. P times P, P squared. Minus PQ minus PR. Main thing, try to keep them in the same order that you did. If you just kind of have like a general rule of alphabetical order, it's easy on the brain, you know, P's, then Q's, then R's. So then P times Q. Let's use a different color, Mr. Fauna still. And then minus Q squared. And then minus QR. Done with you. And then PR minus QR minus R squared. I don't know. I speak for myself. X, Y's, and Z's are so much easier than P's, Q's, and R's, in my personal opinion. It's like when they change the letters up, it's like, wow. Weird, you know. Not hard to multiply them together, harder to keep them in alphabetical order, you know. A, B's, and C's are also pretty easy to deal with, you know, compared to P's, Q's, and R's. So combining like terms, here's my P squared. So got a P squared. Then PQs. So here's some PQs, there's some PQs. Looks like that's it. So they add up to be nothing. So gone with them. Q square, PRs, I should say. Personal record. That's what that stands for. There's another PR. And there's a negative one and a positive one. So don't those add up to be nothing. And then we got us some minus Q squareds. Nice. And then, uh-oh, how much is this? Did those two cancel each other out or not? It's an optical illusion, especially since it's happened twice already. You think it might happen a third time. It does not. That's minus 2 QRs. All right, one negative QR and another negative 1 QR is a negative 2 QRs, and then minus R squared. What made so many things cancel out, though? 1 was a plus, it could be like even a +2 and a -2, like the same coefficients but different signs. Does that kind of make sense? A lot of things are going to cancel. Cool. We'll show work on 1 through 9, especially on this homework, and then you have some more review questions. You know, it tells you where it's at.